Right. Good afternoon, everyone, and welcome to our seventh in the series of CAWASA webinars, Wednesday webinars. And this afternoon, we are pleased to have with us the Operators Without Borders will be our guest presenter, and with Mr. Mike Ippen, his career as a utilities operator with the District of North Vancouver. He began his career with the District of North Vancouver, where he spent 6 years as deputy superintendent before moving to Saanich on Vancouver Island as waterworks manager, human resources manager, and manager of public works. He retired from the city of Victoria in 2017, where he was the utilities manager. Mike has served on the boards of the British Columbia Public Works Association, BC One Coal and BC Water and Wastewater Association, serving a term as president of the BCWWA from 2015 to 2016, and as executive director of BC One Coal until May 2020. Throughout his career, Mike has been an advocate for operator education. He has been an instructor, developed curriculum, and delivered training across British Columbia, Yukon, and Ontario. So I'd like to welcome Mike, and we also have with us other members of the OWB, Operators Without Borders, Valerie Jenkinson, who has been very instrumental in linking us and partnering with us, and as well Madeline, who is listening silently in the background. So over to you, Mike. And participants, please remember to keep your mics on mute when you join, and others who are going to be joining, please keep your mics on mute. And we will take questions. You could place your questions in the chat room, and we will take them after the presentation is complete. Thank you very much. Go ahead, Mike.
Thanks, Ignatius. Thanks for that very kind intro. I'm happy to be here. You'll notice that there's no camera for some reason on my laptop. So as we're going through this presentation, just imagine that my voice is connected to George Clooney. I've been told I look a lot like him. Anyway, we're going to talk a little bit about preventive maintenance in water distribution systems. And one of the things that I want to talk about is basically not just defining preventive maintenance, but determining why we need to do it. There are different philosophies out there around how we do maintenance in water systems, and all of this applies to wastewater collection systems, treatment systems as well, large or small. And what we're really talking about here is looking at how our systems are built up as operators, whether our systems are large or small, rural or more urban or combination. As operators, we inherit these systems. We inherit them if we're a manager. We take over from our predecessor. Our councils set up our budgets and give us the resources, hopefully, that we need to keep the system going. So I want to talk a little bit about what these components look like. We'll dive into pumps a little more specifically in a little bit. But really, what are the whole reasons for doing preventive maintenance as opposed to some of the other philosophies that are out there? So here's one definition. You've probably heard similar ones. PM, or preventive maintenance, basically is done to assure the optimal working conditions, and it conserves the lifespan of the equipment. So, you've got different appurtenances in a water system, from pumps to motors, hydrants, reservoirs, tanks, pressure regulating valves, water meters, the whole list. And they all have different lifespans. You know, when we purchase something new from a manufacturer, either one of or 100 or 1,000 of them, they tell us that you might get a 15-year warranty. They tell us you might get a 1-year warranty. But once it's live in the system and is delivering safe, potable drinking water, it now falls onto us as operators to ensure that it delivers both in accordance of quality, specifications, and according to the budget that we've developed. So for instance, residential water meters, you know, people call them the cash register of the water system, right? Our revenues are derived from usage through the meters. So it needs to be accurate, which means it needs to be tested. So that's just one example. Basically, in the bullet list there, we have to maintain all of those appurtenances in the system. For the pipes themselves, it may mean looking for leaks instead of waiting for them to surface. It may mean flushing and removing sediment or buildup, tuberculation in the pipe. Because basically what we're trying to do is extend the useful life of the system. And I want you to think about your own systems and coming back to the fact that nobody gets a perfect system. Even here, you've probably heard in you know, all sorts of horror stories coming out of places like Flint, Michigan, or Walkerton in Ontario 20 years ago, where the operators weren't able to meet what I'm going to talk about a little later, called the test of due diligence, in terms of making sure that the system is doing what it's meant to do. So the other part of preventive maintenance that really want to talk a little bit about is the planning and budgeting component. That you can't set up your priorities in a water system unless you have done some sort of plan around what the priorities are, whether they are receiving grant monies to replace a major piece of infrastructure like a reservoir or a treatment plant. But it can also be ensuring that you have a budget to do things like an emergency repair of a water main break or a fire hydrant that is no longer operational. All of these are parts of that big puzzle that we call preventive maintenance. And the last bullet there is really critical, is keeping accurate and timely records. And that includes the operators in the field, making sure that they're accurate around whether it's pressure readings, whether it's the information on water sampling results, or just simply how, you know, when you were last at, say, a water meter, and did it operate, or a backflow prevention device, did it operate correctly? Because you can't build up a program without records. And sometimes they're a right pain in the butt to look to do and to keep going. And sometimes it feels like we're buried in paper. On the other hand, the alternative can be quite catastrophic. So, in other words, basically a preventive maintenance program is these things. So, and again, you're wearing your operator hats, I hope. How well do you understand your system? So, you know, I'm not really talking about the systems that I've worked in, but I want you to think about your systems, how it operates, what's its strengths, what are its weaknesses. It may be the power supply that runs the pumps. It might be the reliability or the durability of your treatment plant. But as operators, as you build up your experience in your water system, you get to know where the strengths are and where the weak spots are in a system. Even in the systems I've worked in North Vancouver, because of the high change in elevation between our pressure zones, the weak spots were the very small, undersized reservoirs. And as the population grew in that city, in that municipality, the reservoirs were not able to keep up in summertime, which meant a ton of overtime for operators to go and actually turn pumps on and off by hand to ensure that the water supply didn't fail. not only for domestic supply, but for firefighting. But as operators, you start to know what your system is doing at certain times of the day and different seasons, weather conditions, even in different operating circumstances, like key operators not being able to come to work. So is there an impact on the actual system? Because if the only person that knows how to repair a pump is, well, let's use an example, wins the lottery and is off work for the next 20 years because they're spending all their money, how is the system going to function? So what operators understand about how their system works, and then, of course, not keeping it a secret, but ensuring that that information gets into records, timesheets, repair logs, is really critical, because then you as an operator and some of your senior staff, managers, can start developing, the word there, proactive, means programs that anticipate issues, so that if we can anticipate something happening, we can plan to ensure that it doesn't happen. So if we know that a fire hydrant is not functioning properly and we don't have the spare parts, those parts can be ordered, and a scheduled service will ensure that if there is an emergency or if we need to use that fire hydrant for flushing, it works. As opposed to arriving to start a job and finding valve boxes are buried or paved over or broken and they don't function the way they're supposed to. And that kind of leads into doing a condition assessment. And you can hire consulting engineering firms to do those on a large scale. But really what we're talking about is, as an operator, do you know how your system is functioning? Out of 50 fire hydrants, how many of them work? That's a condition assessment. You can go and dive into further details, like creating data records for each fire hydrant. Maybe some utilities in smaller towns use a rating scale on their actual recipe cards that they use to keep a track of all of the repairs that are done on a certain piece of infrastructure. So it doesn't have to be fancy, doesn't have to be expensive, but really it comes down to overall, how is the system operating, and what are its chances of continuing to operate the next day? And in some places that I've been, the chances aren't good. And I have worked with operators here that are hoping that something doesn't break down until after they've retired, because they know it will be a nightmare to repair. Well, that's not preventive maintenance. That is not looking ahead with the sense of trying to optimize and maintain the system for the ratepayers, for the members of that community, so that whether it's a Sunday in July or a Thursday in December, the system will still perform. And so, and I mentioned in the last bullet there on that slide, certifications. You know, a trained staff is critical to doing preventive maintenance. Otherwise, you don't have the people ready in place to start some of the programs that we're going to talk about. So I hope that makes sense. And again, some people ask, why do it at all? Why not just wait for it to fail? It is expensive to do preventive maintenance, because it means that you're rolling trucks and staff out onto into the distribution system, looking for or turning valves, servicing and testing water meters that are working just fine. So is that doubling up? Some people feel like, well, that raises the overall cost of managing the system to a point where if we have to go back to our council or to ratepayers and say we need more money because we have to have the money to take X number of pumps out of service and get them to the shop and have the motors checked and the impellers replaced. Yes, but the understanding is that if we do it, we can minimize the opportunity. Not prevent entirely, but minimize the opportunity for failure. Yeah, for sure. It doesn't guarantee that a failure won't happen. Utilities, I'd say some of the best run utilities all over the world still have water main breaks, still have flooding, still have power failures. So it's not about perfection. It's about ensuring that whatever the weakest link in the system is, you as an operator are aware of it and know what would have to happen in case that weak link does fail. I'll give you an example. Saanich, where I worked, had some very strange size OD, outside diameter steel pipe. It was put in just after World War II. It had a very small OD, so none of the repair clamps that were standard that the suppliers, we could buy from the suppliers, would make that repair. So it was, well, it's up to us as the operators to ensure that we've ordered those special fittings and that they're not stripped for parts or thrown in a corner that you can't find. Because if you as the operator don't know how to make that repair or don't know what's in the ground, it's very tough to ask your ratepayer for more money, because basically it affects their sense of your reliability and the integrity of the distribution system. In order to do preventive maintenance, yeah, you do have to keep comprehensive and current records. Every opportunity that you have as operators to touch a valve or a hydrant or a water meter is an opportunity to learn something about that asset and ensure that that information, right from, we visited it on July 28th, and these were the operating conditions, and made a note that the drain next to the fire, or at the fire hydrant, was plugged and needs to be repaired, and we didn't have the equipment. All that information you don't want to lose, because without that information, it's very difficult to put together the types of preventive maintenance programs that really work well. And of course, AWWA, the American Waterworks Association, has said for years that really in terms of preventing outbreaks of waterborne disease, the integrity of the pipeline is one thing, but the integrity and knowledge of the operators is huge. Because think of all the opportunities you have as operators every day, that if you haven't got the training or you don't have the experience, you could create a water quality issue. So it's really critical that in order to be effective in your PM programs, operators need to be trained. And utilities overall, large and small, take that very seriously. Sometimes they don't have the resources necessary to train everyone to that level. So again, it's like reallocating the dollars you have where you think they will do the most good. I hope that makes sense. So just as context, it's not always been about preventive maintenance. The American Public Works Association for years operated on this idea that we will fix it when it breaks. So a road, the asphalt crumbles, sinkholes start to develop, erosion into ditches. Okay, that's when we'll go out there and dig it up and repave it, or mill and pave, or do whatever strategy we can. A bridge is starting to fail, or it's undersized, then we'll find the money to make it work. That was a huge philosophy, and a lot of superintendents and managers had very good careers all the way through the early 20th century on that philosophy. A couple of issues around that is that when infrastructure all starts to fail at the same time, 50 years after a building boom, and now we have 20 bridges or 3 dams and 16 reservoirs that need replaced, money in current dollars often not able to be found. An example where I live right now is the schools, the children's schools need upgrade for earthquake. That's one of the big hazards this part of the world. Well, there's not enough money to fix all of the schools at the same time. So the idea of a preventive maintenance program as opposed to just in time is that you can start to determine what your future costs are going to be and start putting that money away. And if council doesn't give you the money, at least you have documents in existence that suggest that we have a shortfall 5 years from now, or right now. I mean, that's quite common, which the just-in-time school doesn't really allow you to do. I worked for a mayor for many years who said, I don't need all this asset information. Just tell me when the thing is about to break, and we'll give you the money then. As you know, for water systems, that's kind of tough. You have 100-year-old cast iron pipe, or in North Vancouver, they had 70-year-old wood stave pipe with a whole series of small leaks. Well, when is that point in the life cycle of that asset to make the repair? Because when it breaks for good and you can't put the water back on in a block or in a city neighborhood, it's too late to start asking for money. The rotational philosophy is still around, and it's basically think about all of your assets and infrastructure and think, all right, I'm going to do, starting like the face of a clock, which a lot of utilities do, due north. We'll start in January, and then we'll get all the way around the utility. By December, we're back to 11:55 p.m., midnight. So we've done what we can, and no matter what, we don't budge from that. A lot of garages will do things like that on vehicles. And yet, unless the actual specifics of the infrastructure are taken into consideration, for instance, in vehicles like high use, low kilometers versus high kilometer usage, that sort of thing, it's very difficult to ensure that the infrastructure survives. Give an example. When I was teaching hydrant maintenance for several cities, it was amazing that all of the cities, it seems very logical, all the hydrants were numbered 1 to 200 or 1 to 1,000 or 1 to 3,000. And the maintenance crews would start at hydrant number 1 in January and work their way through, no matter where hydrant number 2 was. And imagine in your city, if hydrant number 2 is exactly the opposite side of the city, the crews were very good at driving all the way across town to inspect that hydrant. And then number 3 might be right next to number 1, but they'll drive right back and do it in order, numerical order. As I say, any issues, I mean, think about it. We run out of money or you lose operators, and by November, you've only got half the hydrants done. All right, so in January, do you start where you left off? It's amazing how many cities would start with number 1 again because of the rotation, which meant that if you were the one hydrant just past the ability of the crew to do it in 2019, you didn't get done. You may not get done in 2020 either. So these are all have been very popular ideas of how to maintain water systems, but they do fall short. And one of the keys about talking about preventive maintenance, in other words, a proactive approach, is that we want to make sure that our ratepayers are getting the best value for the dollars they have. And that we're doing that by making it as reliable a system as possible. I mentioned earlier, as operators, we all inherit the system that we all had a first day of work. Well, there was a water system there. Very few of us actually create the water system that we work for. So by inheriting it, we inherit all the good things and all the bad things and all the strengths and weaknesses. So as a manager, when I went to a new water system, one of the first things I wanted to look at was the budget. But more importantly than the total dollars spent, I wanted to see where the dollars were being spent compared to the actual reliability or age or condition of the appurtenances. I want to match that up, right? So as a pump mechanic, we'll talk a little bit more about pumps in a bit. I want to make sure that the time I have during a working day and week is spent where it's most needed. And the only way you can do that is by planning and having some sense of prioritizing what are the highest priorities in your area, whether that's in pumps and motors or in the SCADA system or in the treatment plant. Basically having that understanding of how the system works. And again, all of that interlocks and ties together. It allows designers, engineers, managers, superintendents, operators to plan. And that's not just plan today, but to plan next week, next month, next year, and even 5 years out. And the key planning reason for doing that planning is that last bullet, right? The reliability of critical systems. We want the most critical systems to function when they're needed the most. So, talked a little bit about what due diligence is. And due diligence basically, it doesn't mean, if I can say I have done my due diligence, you hear lawyers talk about due diligence and insurance people talking about it. It really means, can I meet the standard that the city has set for me as an operator? So in other words, it doesn't mean having a gold-plated water system that never fails or never experiences low pressure or leaks or the occasional high spike of turbidity or taste and odor issues. That's not it at all. It doesn't mean we never have a failure. But what it does mean is that I, as an operator, have done everything in my abilities and up to the levels I've been trained with the resources the city gives me to plan, to budget, and to, as it says there, minimize risk. So knowing that a pipe that could fail because it's 75 years old, and we don't have the right couplings to make the repair, now you're not meeting the test of due diligence. You know the OD of that pipe, and you know that the repair couplings are 3 months away because they're an oddball fitting. Well, then the due diligence standard is we've ordered 2 of them and we've identified that they are to be used in this segment only, and we've trained staff accordingly. All of this is towards, with a goal. We're not doing it, willy-nilly going off in different directions. We're doing it to increase the reliability of the system, right? So the key word there is reasonableness under due diligence, right? Meeting the standard. We're not looking for perfection. We're not looking for people that never make mistakes, or, heaven's sakes, being a superintendent or a manager kind of goes hand in hand. You make mistakes, but it does mean keeping one eye on the system and doing whatever it takes with the resources that you have to minimize the risk of failure. There was a manager that I supervised for a while who looked after the wastewater collection system, and he really was afraid of a system failure in one portion of the wastewater collection system. And so he spent a lot of money that he didn't have. And he was actually terminated because he was spending money well beyond his authority. But as he said to me, I want to do this because I want to prevent bad things from happening, which is very admirable. But the test of reasonableness means you have to do it within the means that you have. And, your budget is authorized by councils or directors, elected or appointed officials, and those become your parameters, the boundaries that you have to work in. So knowing and understanding what those boundaries are means that you can then plan accordingly. And in most utilities, there's never enough. The budgets are insufficient, and the pipe and the appurtenances are getting older, so that becomes a real issue. So it makes it doubly difficult, but it actually increases the need and the rationale for doing preventive maintenance. So again, an example. So in a just-in-time philosophy, if I was the supervisor looking after water quality, you can tell you're working in a just-in-time type of environment when we only respond to complaints. We don't know what potentially could be happening in the water system, but someone's complained about dirty water, or someone's complained about funny taste. So we go out and we take a sample, and then we get the lab results back, and then we let the resident or the business owner know. We don't go out and flush ahead of time. We wait until either a health authority tells us that we've had a violation, or that people are complaining. We have a little or limited or no understanding of how the system functions. In other words, where our high and low pressures are, because those can fluctuate seasonally, as you know, or time of day. And for those of you working with intermittent systems, what does that do to the water quality situation in your utility, and do you have to adjust accordingly? So operators end up in a just-in-time philosophy with mostly just anecdotal. In other words, stories people tell about how things are. And as operators, we hear a lot of stories. It's one of our best things, is we collect stories about how the system works. Do you remember when the water main on such and such a street or neighborhood exploded and what we had to do to fix it? The bottom line, though, is that when you are just reacting, and that's the common thread here, is that instead of planning, you're responding to either customer complaints or concerns from a health authority or from a business or a resident, or listening to stories that are being told. The bottom line is the system is less reliable and there is a higher risk of failure. But in a PM program, these are the kind of elements that you would expect to see. They're programs developed. In other words, we do sampling, we do monitoring. Where? Well, as operators, you know where those weak links are. Potential where one or two water supplies might be blended, or at the treatment plant, or leaving the treatment plant, or in a reservoir. And we develop those locations and then start our scheduling. And a lot of utilities don't sample as much as they would like to because they don't have the budgets. But they still meet the test of due diligence because they're meeting the health authority's minimum requirement. Sure, they might love to do more sampling, but that's what they have the ability to do. They flush water mains either seasonally or on a rotation, basically weekly or monthly, depending on the types of water quality issues. They use the data that comes from sampling and monitoring to then generate programs. A lot of utilities in the United States use HPCs, heterotrophic plate counts, the results of those samples as thresholds to begin spot flushing. So on top of an annual flushing program, they will do spot flushes wherever sample results exceed 200 CFUs. So they have the sense of being in front of potentially adverse water quality. In other words, they're not just waiting for the complaint to happen. They are looking at data that they collect or others that are working in the utility, and then develop their programs. So now you have a sense of in reaction and planning. And you can apply that to all areas, right? Just using fire hydrants and valves. You think about in your own system, out of the total number of valves, what's your confidence in the fact in that all of those valves will operate when we need them to? And that could simply be, can you get on the operating nut to turn a valve in an emergency? Well, there are lots of places where the valves are 12 feet deep in the colder places in Canada and the United States. And so those standpipes have lots of opportunity to fill up with rock and mud and debris. And if those aren't maintained ahead of time, then it could be a disaster if there is a major emergency, or even a planned tie-in if those valves don't work. The city of Oak Bay, a small municipality not far from where I am, had they were doing a great program. They were replacing all their old fire hydrants because they couldn't get parts for them. And so they had finally the budget to replace the fire hydrant. So they did that. They cut the fire hydrant off the stub. And as they were lifting the fire hydrant out of the ditch, the stub caught the valve and pulled the valve off the main. It was an 18-inch main, and so it instantly flooded their trench and then started flooding the neighborhood. It took them 6 hours to shut the water main down, caused over $1 million worth of damages because they couldn't get on the valves to make a quick shutdown to prevent worse damage. So we talk about due diligence. Due diligence, they were doing it. They were replacing an obsolete fire hydrant. They got the money. They did everything the right way. But as far as the valves were concerned, they still had a just-in-time philosophy and hadn't checked them. And then worst case scenario, the repair, something went wrong, and now you had a critical failure. This was right around Christmas time, so it was cold and wet, and 6 houses people had to be evacuated from. It was not good. So, and that's us as operators thinking we're doing the right thing. So you have to be careful that, you know, when you are planning this kind of work, that you are, as what's said in one of the other slides, minimizing the risk of critical failure. So in hydrants and valves, again, we find out that they're failed oftentimes when they're needed in an emergency. Valve we can't get on, or it's broken and just spins and spins and spins and doesn't do anything. So we have a much higher risk of non-functioning appurtenances. Valves could be shut. A perfect example of a very easy preventive maintenance program is just having a record of which valves are shut and opened. And if you as an operator shut a valve, that's your job to ensure that it's either opened at the end of your shift or some means of recording that it has been closed goes to the next shift, so that it's not left shut unintentionally. Part of it also is, you know, when we find something is broken, we don't have the right parts to make the repair, which of course then will relate to an increased cost. As I mentioned in that Oak Bay example, that failed water main, because of the trying to replace a fire hydrant, cost over $1 million. And the superintendent did not last very much longer because of the way that unfolded. So not only did it cost a lot, it was a very negative impact on the utility's reputation. You're the ones that are supposed to be keeping us, you know, keeping the water system running, and you just did a pretty darn poor job of that. So another example, but with a PM program, those valves, either whether it's an O-ring or whether it's the actual operating nut, we know about it, we fix it before we need that valve again. We schedule programs so we have a sense of, it might take us 5 years to go through the whole city to check the valves, but we don't stop until we've checked it all. Sure, there's nothing wrong with a valve. It hardly ever operates, right? The mains are open until we do something to them, but they better work if, you know, 20 years from now, they're actually needed. So we also then get a sense of what our infrastructure costs to look after, because we can budget labor, materials, and equipment to check all the valves. And if we have 1,000 valves, we can determine a price per valve on an aggregate basis to do preventive maintenance. And that goes into our planning for year 2 and then year 3. Another example, before we start talking about pumps, is water mains themselves, and looking at how cities chase after leaks. And part of the issue in North America is water is very inexpensive, and certainly in this part of the world. And so a lot of cities don't do any looking to replace valves or to fix leaks before they surface. They just wait for the water to show up or someone to call in and saying, I can hear water leaking in my house or water running. Well, that becomes a reactive program. We wait until the leak either shows up on the boulevard or in the road, or it's so bad that someone has no water because of it, and then we go fix it. As opposed to using some of the equipment that's on the market now, and whether it's contractor, in-house staff, to start looking for leaks before they are visible. So again, the difference between a just-in-time type of philosophy versus a preventive maintenance. So I really want those examples to stand out, because it's not hard to start a preventive maintenance program, and a lot of utilities sort of start in some way, but they don't necessarily take it to the nth degree to really take advantage of the benefits of the program. So the American Water Works Association, a very simple mantra for operators: know your system. we mentioned, like, how can you plan and understand how the system works if you don't know what's in the ground? What materials do you use? Is it iron? Is it plastic, C900, or Bionix, or poly? What are the diameters? So how do we find the spare parts? We don't necessarily have to buy all the spare parts. We can have agreements with our suppliers to carry some stock in case of emergency or when we're doing some of our planned work. But to do that, we need to keep records. And as operators, if your hands are touching the infrastructure, then you have the ability to collect data. There's some utilities that do it with barcode scanners, fancy asset management systems, whereas others, well, they just take a record of it on a card, and that card is updated in the office. But basically, all of these bullets, right? Knowing how the system operates all year long, so day, night, summer, winter, wet or dry conditions, peak demand versus minimal demand, because that varies depending on your community. So operators should know that, and it's really important for management of utilities to ensure that those operators are trained so that they have some understanding of what's going on. And some of that is records and using them, not just putting them in a cupboard somewhere, but actually using those records going forward. So let's talk a little bit about pumps, and then I can take some questions. So obviously critical infrastructure, right? Your pumps, motors, whether it's in a treatment plant, but specifically in a distribution system, we're pumping up to elevated storage or we're boosting inline. If we do not have a PM program, there's a risk that a pump may fail, because it's running exceptionally high, or some of its, like its impeller or its bearings are starting to wear, but we don't do anything before it fails. So not good. If you do not have the ability to choose to take a pump out of service and you are simply at the mercy of a pump running and or failing, that's tough, because it's very difficult for operators to maintain standards of efficiency and also safety of the water system if you're waiting and just hoping. It's sort of the idea of fingers and toes crossed every day, and then hopefully nothing goes wrong. Well, it's just math. Statistically, it will fail. The question is when. And that means, are we comfortable not having any spare parts? Do we have the right people to do the repair? And if something fails before we plan to do the repair, it's probably going to be more expensive. And that's kind of the nature of an emergency, and that's okay. Emergencies will still happen in a preventive maintenance program. But if you don't have any sense of how your system is operating, its overall condition, you could have multiple failures concurrent, and then you've got serious issues. And it may not be in the budget. A major pump or motor repair might exceed your operating budget and need to go for council approval, and that may take months. So if you have to do temporary bypass pumping, that's expensive, potential impacts on health and safety as well. But with a PM program, according to your manufacturer specs, you're servicing regularly, keep parts in stock either at your facility or at a supplier's. You're keeping records. Every time you go to a pump house, motor hours, pump hours are logged, system pressures and flows are kept so that you have a sense of how is that pump running. If it takes 6 hours to pump, when yesterday it only took 3 hours, what's changed? Could it be an issue in the pump itself? Could there be a restriction, a valve shut? But without that data, very difficult to know. So a PM program means we're going to do inspections. We're not just going to show up when something breaks, but inspections are done to catch problems before they arise or get worse. And that is really key if, especially in the summertime, people go on holidays, vacation, or retire, is the replacement staff operator trained and understands all of the steps necessary to keep the equipment and tools running. You can tell a lot about how the system is run by how the tools that operators use are kept. Are they chucked into the back of the truck willy-nilly? Are they dirty and rusty? Or no, we know where we can find the tool, we know where we can find the materials, and they're all in good shape. Also increases the pride, that you are, as operators, critical in maintaining the integrity of the water system. And again, it doesn't matter which water system you work for, or how big the budget is, or if they buy you nice shirts to wear. If you're not building on the preventive maintenance program and helping it with more information and data, then again, the risk can be cost, reliability, and basically the reputation of the system. So specifically for pumps, this isn't an exhaustive thing by any means, but just a sense of what kind of things you'd be looking for. They fall into the three categories, right? Pumps, motors, facilities. There's mechanical considerations, electrical components, and civil. And again, inspect and plan so that you have the ability to develop programs around each, budget, and implement. And again, the manufacturers of the equipment can provide you with that information. So you don't have to start from scratch. For mechanical, things like valves, control equipment, the manufacturer will suggest what those inspection cycles are. And by keeping records of running hours, it's not just once a week visiting a pump station or a pump house or once a day in peak times, but it's actually logging the hours running. You as an operator then will start to learn, which pump is working and which isn't, which is starting to slip. We're going to have to pull it and check the impeller or get a service done. And the more you know, then the more specific you can be when work has to take place. So you can either call a contractor or do the work yourself. And again, that last bullet, right? Qualified employees do the work. So again, not just for the safety of the employee, especially working around electrical systems or on electrical systems, but it's also around ensuring that the equipment will last as long as the manufacturer said it would, and you don't void any warranties. Motors, fans, variable speed drives, and all that related equipment. Again, manufacturers will tell you what the inspection criteria are, and whether you call them up when it's new and have them walk you through the actual inspection procedure, or use open source information or AWWA resources to understand how to do the different pieces of inspection and maintenance on a regular basis, right? Again, qualified employees have to be. So that may be certified electricians or contractors with the appropriate tickets to work on those systems. Civil often get overlooked, whether it's taking off the graffiti on the outside of a pump house, whether it's clearing the vents away, from materials that gets piled up, or animals that make home in the vents and screens. All of that is an asset that needs to be maintained. And again, records just as important to keep up to date with those, so that you can look at the integrity of the actual pump house or housing or chamber. Lots of examples about cracking and crumbling pump bases or motor bases that then misalign the pump and the motor, and then you have a failure, equipment failure, which could have been prevented if, in fact, the operators were told or learned how to do inspections for the facilities themselves. And as simple as, are the hatches and ladders and so on, is there proper security, and do they function as they were intended? A lot of specialists in asset management talk about their view when they come into a utility is if the small things aren't being done well, the system might still work, but small things have a tendency to accumulate and potentially escalate. So they always look and see, well, if you're not doing the small things, well, are you really prepared for when larger programs, larger pieces of equipment need to be maintained? So it's an indication, again, looking at your own systems. Are we up to date with our record keeping, with our inspections? Do we know what we need to do to keep a pump or motor running? And again, you all probably have seen these, basically the components of a pump, knowing that all of these aspects need to be inspected. There's a quick cutaway of a small centrifugal pump. If you can't do the work to replace the wear ring and check on the impeller, then who can? And again, if you have to send the pump out to be serviced, what's the best time of year to do that to minimize? And in the hottest weather, probably not good. If you need 2 pumps to run in a station, well, you're gonna have to find a time either when the flows are lower to take it out of service, or find a bypass or a secondary pump to take its place. So again, when you have operators trained in the various aspects of maintenance, there's an example of different types of impellers, and the supplier, it's all the same supplier. These are applications for different types of pumps. They will have lots of information for you about how often it needs to be inspected based on the conditions of the water that you're pumping. If there's grit, it's going to be more often than if the water's already clean. If you're operating a pump at a high end of the pump curve and you get cavitation, then you're going to have to inspect more often. But again, as operators, you start to learn the actual specific operating conditions in your water supply. There's a cutaway of some packing glands, basically. And in this case, if you have to replace the packing yourself, follow the manufacturer's recommendations, make sure the pump and motor are locked out, and that you have the right equipment, not only to pull the rings, the packing apart, but also to replace it and put it, the right packing back in. Otherwise, you end up with more problems than not, right? So here's an example of a pump and motor that they've taken out of service, actually, to work on that. So again, there's one ring missing on the left-hand side at A. Do you know how to do that work? And if you don't, it's up to the utility to find someone, whether it's a contractor or yourself, to do that work. I hope that makes sense. It's basically, you're not starting from scratch. There's a lot of information out there already, but the key is that you're trying to implement inspection and preventive maintenance program. Again, if you have mechanical seals, well, then you've got advantages over packing, but probably you can't do that replacement depending on your shop. So you may bring the manufacturer in to do that work, or pull a pump and take it to them. So utilities are different. In more remote areas, the shops tend to be more self-sufficient, and the mechanics that run them can do a full slate of maintenance work and repair work, because the option of sending that piece of equipment to a city to do the work is not there. Whereas in Vancouver, lots of qualified shops close by, so the cities can meet the test of due diligence. They can take the pump there in an hour, and next day or 2 days later, depending on the work, it's back and ready to go put back in service. So their staff could carry on doing their inspection and maintenance work without interruption. So again, some examples, when you're doing maintenance on the pump, not just investigating, what's happening there, but looking for, is the pump running according to the curves that were created when the pump station or booster station was designed? Is it making, the right sounds? Operators will put their hands on the piping and confirm that the pump is running smoothly. There's not any highly turbocharged water moving through. It's, we're not having these surges by going through the piping irregularly. As operators, once we know how to do this, we do this regularly. It could be weekly, it could be bi-weekly, it could be monthly, depending on how many hours the pumps run. And a lot of times for utilities that have pump stations that only operate in the summer, it's almost more important to do the maintenance in the winter so that when demand periods start to pick up, the equipment works. And much the same philosophy with motors, right? Bearings, the shaft, the windings, are we doing inspections, checking the current, going through that motor to make sure nothing's changing so that in critical usage, the motor does what it's supposed to do. Ball bearings, the same, knowing what the manufacturer's specs are for greasing and lubricating bearings and using the right grease, right? Not just the cheapest, but make sure that then less is more, that you're using the lubricant in the right way, and of course disposing of the old grease correctly. But if you wait for the bearing to fail, then not only do you have the bearing issue, but you could have a shaft issue and the actual motor and or pump itself. Right? There's an example there of someone greasing one of the bearings. And again, make sure that you're doing things. Part of doing the due diligence in terms of PM is when you're trained how to do the bearings or any aspect of maintenance, you can do it safely. And your utility safety procedures, you're up to date on and trained, and you're doing the documentation around that, wearing the PPE, doing the lockout, fall protection as necessary, and so on. Another quick slide there, but basically following, the proper procedures for replacing the grease in a bearing. With windings, oftentimes we can check the load on the windings in the motor, but basically, taking it out of service, it might have to get baked and rewound depending on how long that motor has been in service. And then setting up a program, whether it's annual load test, recording hours of operation, and then having to pull that. Might be 5 years before that motor needs to be pulled, depending on how many hours it works. But the idea is that you, by doing this PM work, have a sense of increasing the reliability of that motor, which is what it's all about. And part of that, the alignment of the shaft, and it could be a very small change in the alignment based on the material pumped. It puts the stress on the impeller, and now the shaft is slightly out of alignment. Well, if we don't ever measure and check it, then by the time there's a failure, now we have multiple problems as a result. So just to wrap up, basically, because I think I'm close to time, really starting a preventive maintenance program, if you don't have one now, it's about changing the mindsets, right, of the staff, but also of the utility, the council, management. Has to include training for the operators, because they cannot create and maintain a preventive maintenance program without being a key part. Management might say, yeah, we're going to do preventive maintenance, but without trained operators, it's very difficult to do, if not impossible. And it includes keeping records, keeping up to date on what we've got in the ground and what condition it's in. And then as a supervisor, adjusting the budgets according to, you may have several years of having to spend more money on hydrants or valves because things have slipped. But then once that's caught up, that money can move into pumps or meters or other areas. Because again, you're being proactive as opposed to reactive. The reward, well, ultimately greater reliability, which gives and durability to the system to survive in the toughest operating circumstances that you have. You provide best value for money. Again, it's not necessarily the cheapest way to go, but it's the best value proposition for your ratepayers. And with that comes increased reputation of the utility. And you as an operator, right? Because you have skills that you've actually been able to use, not just as a custodian, which a lot of times when we just respond to problems is how people think of us, but actually as a skilled operator that is critical in terms of keeping people safe, their water supply safe and reliable. All right, that's basically all that I have. I hope that has helped in some way.
If you could just share your screen with me, Mike, and I'd just like to show that one slide or one document that I have on what goes into setting up.
All right.
You can do that. I don't know if Ignatius has to do that.
Which one is it?
No, it's multiple screens, so you could multiple sharing, so you could share your screen.
Can you see what's on my screen?
Not
No.
yet. No. Well, just ask Mike to pull up here the slide that you want.
No, it's a different one. It's a Microsoft Word.
Oh, I see.
That's on my desktop. And Mike does have a copy of it, but I don't know if he has it.
Well, you could share your screen then, Valerie.
I'm trying to do that.
Yeah, it's coming on.
Share. Can you see that?
Not as yet. It's not come on as yet. No.
Okay, what I was trying to show is just basically when we've gone in and helped a utility set up a PM program, we use the best practices from AWWA and WEF. We do an inventory. It's sort of like a big matrix. You do an inventory of how many hydrants you have, how many, if you've got reservoirs, valve maintenance, and you take a look at what the inventory is that the utility has and what their current service level is, if anything. And then what's the desired service level? You look at how many staff you use, how many hours you're putting towards that, and then what would be required to take it up to a preventative maintenance program. And then you can see what additional budget or additional manpower you need to put in a preventative maintenance program. And in the long term, it saves an enormous amount of money by doing that, even though it might mean an extra person at the beginning, but you're not replacing equipment as you would if things break down, which is what Mike was talking about. So sorry I can't share that with you, but not sure why.
Okay, well, thank you, Valerie, and thank you, Mike. Do we have any questions? I just have only one question in the chat so far, and that's from Ezekiel. You want to go ahead, Ezekiel, and ask a question?
Yes, you mentioned about getting to know where your weakest point is. So my question is, what if your weakest point is not any equipment or any fittings, but then the operator?
That is quite common, and in many ways, as I say, there are examples all over North America where the operators have created potential health risks to the residents because of their inability to understand or lack of training. So the first step is identifying where the weak links are. So it sounds like if the weak link is the operator, then the identification process has happened. Then that's about training and understanding what their responsibilities are, and whether that's management doing the training or outsiders. And again, operators have different strengths, so and experience. In some of the more complex water systems in North America, the operators are so specialized they can't move from water meters to fire hydrants to valves to SCADA because it's just too complicated. Well, so it's up to management to ensure that there's sufficient people trained to back up the key people. But yeah, it's not uncommon that the weakest link is the operator, in which case, and that's where the just-in-time sort of philosophy really took off. You didn't have to train anyone because by the time something failed, people had enough information because they knew specifically what they had to do. They had to dig up a broken water main, as opposed to learn how to look for leaks that don't surface. So there is a commitment from the whole utility to a certain level of training. you kind of know when you get there, right? Because you're able to actually implement the PM program.
Okay, thank you.
Yeah, I hope that helps.
Any other questions? Everybody seems very quiet in the no questions in the chat room. I did place a link for our Menti meter so that we could get a little response from you. And it's up already. So if you go to, those of you who have the ability to go to mentimeter.com, the link is there, and you just got to put in the code, and you could just give a quick response and just a quick evaluation and your response to the webinar so far. I can just share with you if I share my screen now. You'll see what it's all about. Share my screen. But if you have not, then you have a couple days after the webinar to just give us some response to the question. You can just put in your own words, and the link is right there. And if you have no further questions for Mike, I would like to thank him immensely for taking the time to be with us this evening, and for you to participate, and as well Valerie and Madeline. This has been very good of the Operators Without Borders to share with us their knowledge, and we hope that you have received it well, and that you will be able to impart some of that among your colleagues and at your workplaces. So we try to keep doing that and keep you abreast with developments in the sector, as well as we go through this difficult period, that we can find other avenues to offer training and use expertise that can be available to us within the region and externally, as far as British Columbia's Operators Without Borders are doing. So I'm not hearing anyone again. I'd just like to thank everyone. And thank you, Mike.
Thank you very much, Ignatius, for all the work you do to make this possible. Thank you.
Yeah.
Thank you very much, all. It was a very good presentation.
Oh, I think, oh, that's another matter, Ezekiel. I'll chat to you. Well, just, Ezekiel, just let them send in an email, and we will, to us, and we will send the certificates. So we have the contacts, and Valerie will take care of that promptly. Okay, good evening, everyone.
Ezekiel,
Thank you.
all the certificates have been sent out, so maybe I haven't got the right address. Or you're not with DeWasco, are you?
Yeah, Ezekiel is with DeWasco.
Okay, DeWasco, all the certificates went to Bernadette enough because I didn't have the addresses on the original.
Okay, I have those, Valerie, so I will single them out.
Bernadette enough was sent all of the in a folder, all the certificates.
And he has said that he has sent it over to the HR manager to attend to. So I'll follow up on that. Okay, thank you very much, Mike. Thank you, Valerie. Goodbye, everyone.
Thank you.
Thank you
Goodbye.
for
Thanks,
participation.
Mike.
Okay, bye.